Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Caines, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we're following on actually from our episode that we released the first part last week with Scott, and then we're releasing the second part now and continuing on with his recent talk and discussion kind of in more in depth about it. So hope you enjoy the show. And yeah, so following on from that, then you then start looking at separating out the client, the idea of this client. How do you interact with the behavior and the state? And actually, your involvement with it then becomes a little, you kind of split the two. And you talk about batch commands, and this is quite a common pattern. And the idea of you adding commands, which are essentially like data equivalents then of the desired behaviors, and it's another process's problem or another computation's problem to handle dealing with it, handling the state, doing the behavior. I'm just wondering when have you found this to be a good technique? Is there a lot of places you can incorporate this approach?
Yeah, well, the batch one is basically the most. I kind of take this batch thing and I evolve it into actors and event sourcing and so on, later on. But there's the idea of instead of calling functions, turn the functions into you have data, and then the data is interpreted by somebody else. And the nice thing about data is you can pass it over the wire, and even if you don't pass it over the wire, you've completely decoupled the client from the server or the person who interprets the data. And that's, we're always trying, as developers, we always want to have an architecture which is as decoupled as possible. We really want to minimize any kind of coupling, any kind of dependencies between our two components. And so by using data rather than having function calls, that's a great way of doing that. And one of the nice things about a functional language is that because you have union types or choice types, it's really easy to create a type that represents all the different commands you can do. So the batch example was just the very kind of lowest level example of doing that, where you have a command to move forward or a command to put the pen down or whatever, and you can just send that to something that runs those commands.
Yeah, because you can be very expressive, and you did show in that talk, the expressiveness of these data types. Following on from that, actually, then you then moved on to the actor model. What is the difference then between the batch command approach and then the actor model? Is it kind of a one level up?
Yeah, I mean, the thing about a batch is it's a batch command. I mean, you basically run it, and then everything happens you have to run the batch, so you have no feedback while you're doing it. With the actor model, you basically it's more instantaneous. So I send one command, and then it handles it straight away. And then I send another command and it handles that straight away. So I get instant feedback. It's kind of not exactly real time, but it's, near real time responsiveness. Of course, doing that makes it more complicated, because you have to have, the actor has to be in memory all the time. It has to keep track of its state. It has to have a live message queue and so on and so forth. But you can see why the actor model is very popular, because it's a great way of getting the benefits of decoupling and having someone else manage the state for you, but still feel like a kind of live program.
And this is then the actor model. Then I'm right in thinking is what Alan Kay really thought OO as being.
Yeah, he was very anthropomorphic. So the idea with the objects is they were little people. And just like with people, you ask somebody, I say, please, can you open the window? Please, can you go over there and do that? And I don't care how you do it. I'm just I give you a request, and you do it in the way that you think is fit. And so that was his idea of how objects should work, is they're kind of anthropomorphic. They represent real things, and you ask them to do something, and how they do it and what they need to keep track of to do it is their problem and not your problem. So, and the actor model was invented independently around the same time in the early 70s. It wasn't really OO, but it was the same. There was a lot of that in the air at the time, and so it wasn't clear until afterwards, because Smalltalk didn't use the message queues directly. I mean, it had a kind of internal dispatch model. But, nowadays, the actor model aligns very closely to this exact same thing of encapsulated objects that you send messages to, and they do it. And I mean, the thing about the actor model is, in a pure actor model, it's a one-way communication. You send a message and that's it. It's fire and forget. You know, if you want the thing to tell you it's finished, it has to send you a message in return. So it's a very different model from, you know, classic traditional programming. So there's some gotchas with it, you know. And again, so this is in the actor model, everything is very opaque. Everything's a black box. The actors are black boxes, and that's deliberate. I mean, that's the whole point of doing it that way. I mean, the actors rapidly are very close to being microservices. Not a lot of difference, I mean, in some ways. Within the implementation inside the actor can be pure function. So for testing the actor logic, I would give it a, you know, if it's, you know, here's the state, here's the input, and you should generate this output. So you can certainly have purely functional actors. But from the big picture, they're harder to work with because they're hard to compose. They're hard to see what's going on. So doing kind of integration testing, functional testing is kind of trickier with actors. And there's a lot more. It tends to you can get, just like you have spaghetti code, you can have spaghetti actors. You know, where every actor is talking to some other actor. You know, and you've no idea who's talking to who and what's really going on. And just keeping track of dependencies is quite hard.
That's really interesting. And then following on from that, then you mentioned a very, you know, highly buzzworthy thing, event sourcing.
Yes.
And that's become a very interesting and a lot of people are kind of looking into that. I'm just wondering, what actually is event sourcing?
So event sourcing is, again, the idea is that rather than keeping the final state in memory, you keep track of the differences, because every time you change your state, like something happens and, you know, your state changes from A to B, rather than only keeping the most recent version of the state, you keep all the diffs of the state, and you store those diffs in a storage, and then when you want to recreate the state, you just load up all the diffs and rerun them, and that gives you the latest state. So it's a bit like, you know, losing source control or something. You don't always just keep the latest copy of the code, you keep all the versions that led to the copy. And so it has the benefits. You get the benefits of being able to replay things, which is great for debugging. From a business point of view, you get an audit trail of everything that happened. Often the events can capture business processes that you wouldn't capture if you just had the latest state. The classic example is if I got an online e-commerce site and I put something in my shopping cart and then I take it out again, my shopping cart's empty. But the fact that I put it in and then took it out again, that might be really interesting from a business analysis point of view. That is not captured if you only have the latest state. If you just say, oh, your basket's empty, you can't tell whether it started off empty or whether I added a bunch of stuff and then took a bunch of stuff out. They're the same from a final state point of view, they're the same thing. But from the process of how you got there, for a lot of business applications, you know, the journey, in a sense, is more important than the destination, or just as important as the destination. It's like, how did I get here? Is the kind of question that gets asked quite a lot in business. And event sourcing, and also for developers, I mean, from debugging point of view, it's like, how did we get to this state? What's the history? How can I figure out why did we get here? Having all the steps that led up to that state can be really valuable. So that's sort of the benefits of event sourcing, and obviously there's, you know, techniques to actually make that happen in practice. It's more complicated than just, you know, there's always a trade-off. It's a lot more complicated to implement in some ways, but the benefits are there, you know, for a lot of people. So I just wanted to present that as yet another option for people to think about.
Well, no, I think it's really interesting. And it is one, as you say, you mentioned the fact that, you know, your customer will ask these questions, or you'll be asked like, okay, so it was very important. Like, when did they remove that, you know, and all these things. And historically, you know, well, in the past, you'd have to preempt this, you know, it was storing data and only knowing the current state, you know, you would have to provide logging throughout. And it's been able to go back and do different projections and being able to see this information, and nothing's ever lost. And it's always been able to get back up to a certain state and be able to replay things. Maybe, oh, let's see what would happen if this, you know, if we were at this point again and we replayed it using this type of, you know, action or these type of things. You're able to explore a bit more.
Yeah, I think one of the things that's changed is that the cost of storage is so cheap now. I mean, when a megabyte of disk space costs you $5,000, you didn't want to store extra data, you know. But now that you literally from a practical point of view, it's unlimited how much data you can store. It's so cheap. And so, storing 10,000 events, rather than storing the customer data, you can store the 10,000 things that led up to the customer data. Yeah, so it takes up a lot more space, but so what? I think part of that is, if the whole thing of you can never have too much data is definitely kind of one of the trendy things right now. Is always store more, store everything that ever happened and figure out what it means afterwards. And I guess another way of thinking about it is it does decouple that goes into the next step, which is the sort of stream processing, which is separating what happened from what it means. So with event sourcing and with stream processing, which is sort of the next step after that, you basically say, this is what happened, and then what does that mean? That can be a separate step, because sometimes the interpretation of what happened can change over time. So rather than trying to, in a lot of, in traditional kind of CRUD apps, what happens and how you interpret that are in the same piece of code, and they're kind of tied together completely. But if you can separate what happened from how to interpret it, then that gives you a lot more flexibility if new business rules happen, or if you need to interpret it in different ways. In one way you care about this kind of thing, again, the e-commerce might be an example where the business people, the people who care about money, might want to interpret everything about how much money was made or lost. For people who care about marketing, they might care about customer behavior, what items did they click on, and how long did they spend on each page, all that kind of stuff. So the fact that you can separate the interpretation from the data is actually quite a powerful technique. And so I talk about that in other, going on in the rest of the talk as well a couple of times.
Yeah, and actually it's interesting because we've explored this at work, the idea of events, and there's been a couple of, one of the things that's been very interesting with it is the fact that, like you said, the fact that you can explore what you've done compared to what you want to do with it in very different ways. But also we found that testing it is very easy, because it is just the fact of, okay, we've got this very declarative set of events, these pure functions, this reduced state, what actually happened. Yeah,
exactly. Again, it makes everything it also goes to this thing of transparency again. The more transparent it is, the more that the inputs and outputs are very explicit, the easier it is to test, the easier it is to put it into a certain state and see what happens and to play with it. And so, I think that's one of the reasons. There's many reasons why it's popular. I think it's a very nice model of working thing. It doesn't play very well with traditional SQL databases and traditional relational model of reporting, but it certainly is great for kind of the time-based model of reporting, which is also now very important.
Absolutely. I think it's one thing, with like the Flux model, the Facebook Flux model, and in the Redux model, where, you are just dispatching these actions, these events, essentially, that are just data, and they're able then to replay and go through. And obviously just being able to send that off for debug, you're able to get yourself into a state exactly where they were at, as opposed to just knowing the final step. It's very hard to know something that's just an aggregate, just a computed value. It's better off knowing the true, source of truth data, which is what these are.
Exactly. And it's the same reason why as developers, we like source control. It's like, I want to be able to see what changed between, one commit and another. If I didn't have that, it's kind of, you feel like once you get used to it, I think this is a relatively new paradigm, but I think once you get used to it, it's very hard to go back. Just like it's hard, once you're used to source control, it's very hard to go back. And what's interesting is that this model is actually very old. There's a famous quote by Pat Helland, I think, which is that accountants don't use erasers. Accountants don't keep track of how much money you have. They keep track of every input and output to your bank. Now, how much money you have, you work out afterwards by adding all that stuff up. But what you actually record in your ledger is the change to your bank amount. You change to how much money you have. You don't record the totals. You record the changes. And if you made a mistake, you write down another change which compensates for the mistake. So you don't erase the mistakes and pretend they never happened. Everything is always added on. It's an append-only model, and that's 1,000 years old. So people have been doing that, well, maybe not 1,000 years old, but it's a very old model of accounting. So we're just as developers, we're quite late to the party here.
Yeah. And you touched a bit on stream processing, and like the idea of FRP, functional reactive programming, is another really hot topic, and a lot of people are doing it. I'm just wondering, what is stream programming then compared to event sourcing? I know you touched on it a little bit, but maybe just expand on that a bit more.
Yeah, well, I mean, with event sourcing, you have an input. If you start chaining these things together, where the output of one process is another bunch of events, which is then the input for somebody else, and they spit out another bunch of events, which is the input for somebody else. You have these event streams, and the event streams become the major source of input for people. So that's you rather than working with a database where you have to read records and stuff, you have a stream of events, and that's what you work off in terms of doing your understanding of how the system works. And so it's reactive in the sense that you don't go and fetch the data. The data is fed to you. And this is in order to make this work, you need a infrastructure that supports event streams. Something as simple as an RSS feed will work, but the things like event store, the event store database, or Kafka, or I don't know. There's a whole bunch of ways of doing it. But you need to. It's a nicer model. But the infrastructure is very different from what most people are used to. But again, you get by having these little mini processes. I hate to say, I'm not going to call them microservices, but you can see where microservices fit totally into this model. You have these mini things. Each of them does one thing. It takes a bunch of events and says, based on these events, I think this other thing happened, and it spits out another event for the next person to consume. And that's a very, for certain business models, that's an extremely useful way of doing things.
And actually, with both of these past things, functional reactive programming and event sourcing, have you used these in real life projects?
To be honest, I've just played with them myself. Obviously, other people have used them. So I wouldn't call myself an expert in actually implementing this kind of stuff. I'm just trying to explain it to myself and explain to other people. In terms of the stream processing, Jet.com, the e-commerce company which uses F#, had been quite successful using this approach for actual, real life business. And I mean, I'm sure there are many other examples of people doing this. I think LinkedIn, the guy at LinkedIn, I think Kafka came from that. I'm not sure, but other people have done very, very similar things. So if you want real implementation stories, I'm sure there's quite a few out there.
And finally, actually, then you go into another segment, and this is actually like handling dependencies. So dependencies are everywhere, and like the idea of behavioural dependencies, and moving away from hard-coded dependencies into the idea of being able to inject them in. And you do mention, the object-oriented way and then the functional way.
Yeah.
And I'm just wondering, what are the pros and cons of both? Like, do you have anything nice to say about the object-oriented way? Is there, compared to using a functional approach?
I think
the silence tells it all.
I think the problem with the object-oriented way is that you end up. There's a couple of different problems. The first problem is that you need the language. Most object-oriented language, I don't know any do, don't really support dependency injection kind of naturally. You have to write interfaces, and then you have to write classes, and then you need to pass all the interfaces around to inject them in the constructor and so on. A lot of people use IOC containers or frameworks to help you do this. There's just you ends up with quite a lot of overhead. Just the actual mechanism, or you use something horrible like Spring. Everything's in a
XML.
A giant XML file, and it loads it all up and sets it all up that way. That's not so good. But there's another problem, which is that the thing that you tend to inject in an object-oriented system is an interface, and interfaces can have more than one method. And often they do, and often they have lots and lots of methods. And every time you say, I just need this extra method, let me just bung it on this interface. And now all of a sudden I've got implicit, unexpected dependencies. Like, I didn't really want someone to have access to that method, but I couldn't be bothered to add a new parameter to the constructor because it would break all my code. And so you end up with these interfaces which tend to get bigger and bigger. And I mean, there's guidelines. Don't do that. The interface segregation principle. Don't force people to have don't have things on the interface that people aren't using. But it's a principle, and it's not enforced. The natural tendency in OO is to make things bigger that way. It's so much easier to add a method than it is to try and add a new parameter. So it becomes, you tend to get bad habits. It's so easy. In the functional model, you don't pass interfaces, you pass functions. And if I need another dependency, I have to pass another parameter. And that naturally has a counter force to you having too many parameters. You tend not to want to pass 40 parameters to a function. You could easily pass 40 methods in one single interface, but you don't want to be passing 40 parameters to a function. So you don't need the interface segregation principle because you're not going to do that, So, and the functional languages have partial application built in. So if I add a new parameter to a new dependency to one of my functions, I can just partially apply it, and then anyone downstream of that never even knew it existed. From their point of view, they've just got a function that did what it did before, and the fact that it had this extra parameter baked in is invisible to them. So you don't need dependency injection libraries and stuff in a functional model. So yeah, I think the functional model is nicer. It's everything. It's one way I like to explain it to OO people is that if you take the interface segregation principle seriously, you should have, all interfaces should only have one method, and at that point it's basically a function. So you can. It's a bit of a glib argument. You can, there's counter arguments to that too, but that's just a quick way of explaining why I think functions are nicer. There are problems with passing in functions as well, but I think the problems are less than they are with OO style dependency injection.
Yeah, because it's really interesting actually, because there's the two types of OO-DI, dependency injection, and it's the idea of constructor first method. And is actually, you think of it really at a method level, you're thinking, okay, I'm passing in an interface, but this interface, you can actually really explode that out, splat it out into every different function that interface actually has, which is really what you're depending on in that method. But then in the constructor, if you're just passing something in the constructor, you're then giving access to that dependency within every method that you have within that class now, or that object instance.
Exactly.
Which then explodes it out even more, which is very interesting when people, I was going to say, like, my argument then would be, oh, what about method dependency injection? But really, when what you just mentioned, the fact that ISP, we're really looking at interfaces, people just add methods onto an interface. And yeah, there is that kind of thing of, well, I'm only passing in one parameter, but really that isn't one parameter. That is how many of those functions in that interface. It's a really, as you say, it's more declarative and it's more expressive, the functional approach, and it's really more explicit of what's going on.
Yeah, exactly. It's again of trying to hide, especially in large projects, anything that can go wrong. Any dependency that can be taken will be taken, and this goes all the way back, even back in the early 70s. The whole thing of information hiding. If you expose something in an interface, somebody somewhere will use it.
It's the path of least resistance, isn't it? You're just like, I can grab that. Exactly. Great, it's an easy commit there.
Exactly. Basically, that's just our nature as developers. It's like, oh look, I'll use that, and you end up with dependencies that you didn't necessarily want people to have. Or it's a security hole. Another example is if you have a database interface or a repository interface, and it allows you to update a customer, but it also allows you to delete a customer or change their password or something. You could accidentally have a piece of code that deletes a customer when they weren't supposed to be able to do that because someone made a mistake in their code or deliberately made a. So there's security holes and chances for errors. So yeah, I like to be much more explicit. This particular function needs these three things. This other function doesn't need all three things, it only needs one of them. So why pass in all those three things?
Following on from that is, and this is probably a bit of a big topic, but the concept of an interpreter, and it really kind of goes into this free monad, but I won't really, say that too much. But what is the idea then that you're brought up as an interpreter?
Well, it's actually not that far away from the batch model. So in the batch model, you turn a function call into a data structure. So one of the, you just pass in all the parameters and the name of the function, and you pass that you turn that into a data structure and you pass it to somebody who is then going to basically interpret that, say, oh, you want this function, let me call that function with those parameters that you gave me. The problem with the batch model is that there's no feedback. You can't make a decision based on the output of that call. So the person who's running the batch isn't going to stop halfway through and say, actually, this thing, return this, what would you like to do now? The batch model doesn't support that. But then the interpreter model basically does. So the interpreter model is that not only do you pass in the function that you want to call and the parameters, you also pass in a callback, as it were, that so when that function it gets executed, the output of that function can be returned to you. And you can then make a decision based on that. In the turtle example, I have the thing where you hit the wall and you make a decision based on hitting the wall. So it's more complicated, but what it does allow you to do is it completely decouples you, just like with the batch model. The implementation is completely decoupled from the API, as it were. So the interpreter model is the API is the data structure that contains all the operations that you can do and the parameters for the operations, but it has absolutely nothing to do with how those things actually get implemented. So they have to, at some point, that data structure gets interpreted. It's almost like a little program. It is just basically a program. It's a program that says, here's something I want to do, and when you've done this step, ask me what I want to do next, and if you give this, I'll do this. And the program itself, or this data structure, is then interpreted by an interpreter. And because it's interpreted, you can have multiple different interpreters look at the same data structure and do something completely different. So for testing, it's fantastic because you can set up the data structure and then you can test it without doing any I/O. For example, you can pretend to be hitting a database and not actually do it. You can interpret the same thing in different ways for different reasons. So in my turtle example, I have one thing which moves a physical turtle, but another interpreter can just keep track of the distance that you moved so that it knows when to change your batteries or something. You can have multiple interpreters for the same thing. And so it really, really is very flexible. More work, more complicated, but more powerful too.
That's it. The rewards in certain cases are worth the investment.
Yeah.
And it's actually very similar, I feel. Isn't it very similar to the async way, that you're kind of delegating what should happen based on, you're giving it the action of what I want to happen, but it decides when it wants to do that.
Yes, it's a callback. The async model is you do something and then call me back when it's done, and the interpreter is analogous to that too. It's run this function, and when it's done, it's not quite the same thing as a callback. It's sort of similar to a callback, except the callback in this case in the interpreter model gives you back a new program to run. So if the async, each step it's just a callback that just what to do next, but it has no. The next thing you do doesn't have to be another async; it can be anything. With the interpreter model, the next thing you have to do has to be another step in the program. So you have to build up the entire program in memory as a data structure, and then you run that entire program
without even running it. You can then build it up before you even run anything.
Exactly. Yeah, so it's almost. It's very similar to writing code. If you're writing in .NET, you have a bytecode or Java. There's bytecode that's output, and then that bytecode is then interpreted by the bytecode interpreter, or anything. So it's funny you're writing a program using a programming language to write a kind of program that gets interpreted in your programming language. It seems that might be overkill, but like I say, it really does allow you to completely separate or isolate. It forces you to focus on the API. It's like, here's 5 things I can do. Here's the 5 functions I can call. I literally cannot have any idea of how it's implemented because I'm creating a data structure and I have no idea how it's going to be interpreted.
And actually, it brings up the continuation parsing style. And I'm just wondering kind of what your thoughts are of CPS.
Yeah, again, CPS is very interesting. I think it's hard to use in practice. A lot of these things, in fact, I think the continuation, that's the most fundamental style. All monads, for example, I think can be reduced to like a continuation monad. And so the continuations are basically the most fundamental thing you can do. And I think even a lot of compilers actually convert things to continuation parsing style as part of their compiler logic because it's easier to understand how variables are used and for register allocation and so on and so forth. But I'm not a compiler expert, but it is a great technique. I think the consensus is it's a very interesting technique. To actually use it in practice is kind of painful. So these in F#, the kind of computation expressions, there's various tricks to make it easier to work with and to have specific examples. So the interpreter is a particular example. Async is another example, which are kind of targeted to particular uses and not just have a completely generic one, which is kind of hard to understand.
And finally, and we have actually covered almost all of them then, is the compatibility-based API. And this one was one of the ones where I just had an aha moment thinking, I've never thought about actually implementing this in code. I've used it in HATOS and REST-based setting, but never in actual code have I thought about this. So I'm just wondering, what it actually is then, this concept of a compatibility...
Capability, I call it.
Capability. Sorry.
So,
Sorry.
Yeah, capability is just something that you can do. And it originally came from the world of security modeling, where capability is, do you have the capability to write to the disk? Do you have the capability to, open a socket or something? And, if you only have those capabilities, or by limiting what capabilities you have, you can, it's a security kind of feature. So I'm using that, though not in a way of security, but as a way of documenting the API again. A lot of this stuff is about how can you express the API to the client in such a way that the client can't screw it up. And so the capability model is rather than using data structures again. Now I'm going back to using functions. So in a Turtle API, you might say, if it was a JSON thing that you're passing to the web service, you might say, I want to move here, I want to do this. In the capability model, rather than saying, just call this data structure and call this endpoint, and if something goes wrong, I'll give you an error message, the capability says, I'm actually going to tell you what you can and can't do, and you'll only be able to call the things I let you call. So I'm going to give you back a bunch of functions, and if you can't move because you've hit the edge of the thing, I'm not going to give you a function that allows you to move. And if you can't put the pen down because the battery's dead or something, I'm not going to give you that function. So you don't have to call the function and then me give you an error message. You literally will not be able to do anything bad because you will not have the function that allows you to do that. So it's more, you can think of it almost like a dynamic API, an API that kind of changes as you move into different states in the program. Websites are a good example. When I go to a website and I'm not logged in, the only function in many cases I can do is log in. But once I've logged in, I can, post a message and I can edit my profile. If I go to the profile page, I can't post a message. I can change my address and my email, and or I can log out. At each step in the process, there's only a limited number of things you can do, and the capability model is a way of explicitly expressing that. At any given state in the system, there's only a certain number of things you can do, and those are the things which are exposed to the caller, which is why it's a natural connection with the RESTful model, because that's exactly how the hypertext as the engine of application state works. You pass back a bunch of links in the HTML, and if the link's there, you can run it, and if the link's not there, you can't run it. So, but to me, it's a more general approach. It's not just for that. It works, for any kind of thing, especially if you care about security, if you care about people not wanting to do something bad, you literally don't give them the capability to do it, and then you don't have to test, don't let them do it and then tell them they can't. It's just don't let them do it in the first place.
Well, and also, with the REST model, it allows you a escape hook to be able to say, look, I want to change this ability now. When I'm in this state now, I can move or something. It allows you to control what they can do and change over time.
Yes, and that's one of the big advantages is that, especially for the hypertext thing, is that rather than if you know what the API is, people tend to hard code the client to the API. If REST, people end up hard coding the links into the code. It's like if I want to edit a customer, I go to customer/edit/ID. And that means it's really hard to change the API because you've now got an explicit dependency between what the client knows. It has to know exactly how the server works in order to call the API. With the capability model, it's much more dynamic. It forces the client not to be coupled to the server. The client always has to ask, can I do this? Here's the things I can do. Can I do this? Can I do that? And it's also more exploratory because if a new feature becomes available, it can get added to that list and it's not going to break any of the existing clients. And if a feature is no longer available, you can kill it and it can't break any of the clients because none of the clients have hard coded that feature into their usage. They can't because, it's an optional function. So yes, I think it's a very interesting model. I don't know that anyone's actually used it too much in anger, but I think it's got a lot of potential. Certainly, it's a good way. It's an interesting model to think about. Yeah.
I say, thank you so much, Scott, again for coming on the show.
Oh, yeah.
I know I think we've racked up an hour and 45 minutes of your time, so I really appreciate it. It's really interesting.
Good. It's just fun. I'm happy to waffle on about this kind of stuff anytime.
On that note, then, obviously you've got I'll put all of these things in the show notes and your NDC talk that you did, this year. I was wondering, is there any bits on that you did on the recorded version maybe that you wish to elaborate on? Is there any other solutions that you didn't get a chance? Because I know you said there was 15 of them actually on your blog post. Are there any interesting other bits that you'd like to maybe explain? Or
no, I think I took I think those are the most interesting ones in the talk. 13's a kind of arbitrary number, so I had to do that because it had to match the poem, but I think they are different. I think it's interesting enough. I wouldn't want to overwhelm people with more different ways of doing it. I think it's certainly enough. One of the people posted on the blog said, okay, here's 13 different ways to do something. Which one should I use? And I said, that's a good question. The answer is use the simplest one that gets the job done. Don't dive into the complicated stuff just because it's there. So all these things, event sourcing and reactive FRP and also, yeah, it's interesting. But if you don't need it, don't make your life complicated. Keep things simple is my number thing. Play with these things, but don't actually put them in production unless you really need to.
Absolutely. I think that's a great place to end. And again, Scott, thank you so much, man. We definitely have to have you on the show again if you're up for coming on.
Cheers, then.
Brilliant. Awesome. Well, audience, it's been another great episode, and we'll speak to you again next week. Goodbye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.